In this video, we're going to go over how to add and subtract rational expressions where the denominators are not the same. They're going to be a little simpler to start, and then in a second video, I'm going to come back to you with a little bit more factoring that's involved with this. Either way, you're going to be rocking them. Let's do it together. So the instructions say simplify and state any restrictions. So the first thing I notice here is we do not have a common denominator. Okay, so this is just like if you were adding, let's say, I don't know, 3/4 or subtracting 3/4 minus 5/8 or 5/10. You do not subtract those to give you -2 over 6, right? We need a common denominator. So we need both of these to have the least common multiple or the least common denominator, which would be what is the smallest number that 4 and 10 both go into. In this case, it would be 20, and you would multiply the top and bottom by whatever number gets us there. So that'd be multiplied by 5, and this would be multiplied by 2. And that would give us the 20ths that we need. And then, of course, you combine the like terms of the numerators and keep the denominator the same. So I mentioned that because what we're about to do is the same thing. You want the smallest number that both x and 2x squared go into evenly. Now I have an easy way of discovering what that's going to be. Some people will just see it, in which case that's great. Go for it. I think it's easier to ask the question, what factors does this have that this doesn't? And what factors does this have that this does not? And then you have to multiply each of these to get them to be the same. So 2x squared is 2x times x. So this has every factor that x does. But x doesn't have a 2x in it. We'd have to multiply it by 2x to get 2x squared. So our common denominator is going to be 2x squared. So you get 2x squared minus and then 2x squared. We're not multiplying this fraction by anything because we've already got 2x squared. So it's 5 over 2x squared. To get 2x squared in the bottom, you would have had to have multiplied this by 2x. And then you have to multiply the numerator by anything you multiply the denominator by to keep the fraction equal. 3 times 2x is 6x. So what we have remaining now is 6x over 2x squared minus 5 over 2x squared. Now we keep the denominators the same as we saw in an earlier video. Keep them the same. And subtract the numerators, 6x minus 5. Now there's nothing left to factor, so we're done. We're good. Nothing to factor out, nothing to divide out. But you do need your restrictions. X cannot equal 0 because if x was 0, that would make the denominator 0. Okay, so now on to part B. Well, in B, we've got 1 over x plus 1 plus 3 over x plus 4. Okay, well, what factors does this have that this doesn't? It's got an x plus 1. So that means that this fraction on the right needs an x plus 1. Let's put it in there. Whatever we multiply by in the denominator, we need to do in the numerator. On the left-hand side, we've got x plus 4 on the right side, I should say, which is not what x plus 1 has. So we'll multiply top and bottom by x plus 4. And now if you take a look at the two denominators, they will be identical. X plus 1 times x plus 4. So we've got our common denominator. Write it all over 1. I think it makes life a little easier. So there's our common denominator. And now we're going to combine what's going on in the numerators. So I've got x plus 4 times 1 is x plus 4. Plus, I'm going to distribute here. 3 times x, 3 times 3, or 3 times 1. So 3x plus 3. That's just, again, distributing right here. And now all I have to do is combine the like terms. So I end up with 4x, 3x and x, and then 4 plus 3. So I get 4x plus 7 all over, keeping that denominator, x plus 1 times x plus 4. And of course, we're going to state our restrictions. The numbers that make our denominator 0, x cannot equal -1 or -4. That's it. Not bad. So again, we need to get the denominators to be the same. Ask that question. What factor or factors does this have that this doesn't? What does this have that this doesn't? Let's take a look. 5a has everything that 5 has. 5 doesn't have an a, so we'll make it have an a. We want to make them equal by multiplying by as few things as possible, as few factors as possible. So that gives me 2 over 5a and then 3a over 5a. So that's going to be over 5a, that's our common denominator. You're now combining 2 plus 3a. Ooh, we're done. Now some people will want to write that in standard form, right? 3a plus 2 over 5a. That's highest power to lowest. Now, the one thing that we've got to look out for is that restriction. A cannot equal 0 because that would make the denominator 0. Not bad. All right, one more problem. So let's hit this one. We got some subtraction here, not a big deal. What does this denominator have that this one doesn't? An m squared. So I'm going to have to multiply everything here, numerator and denominator, by m squared. But there's a factor of m minus 3 here that this doesn't have. So I have to multiply this now by m minus 3. Ooh, no sweat. Now, what we're going to do is make sure everything is now over our common denominator, which is m squared times m minus 3. Beautiful. So I'm going to again do that distribution to save ourselves a step. 7 times m is 7m. 7 times negative 3 is negative 21. M squared times 2m. Careful, it's subtraction. 2m times m squared is 2m cubed. It's minus 2m cubed. And we want to put that in standard form. So that's going to be negative 2m cubed. That negative sign stays, of course, with the 2m cubed. Plus 7m minus 21. And that is all over m squared times m minus 3. Now, as far as restrictions go, m cannot equal 0 because 0 squared would give us 0. And m cannot equal 3 because 3 minus 3 is 0. Voila! Not bad. All right, in a later video, we're going to go over what happens when you need to do some factoring along the way. The moral of the story is get the denominators to be the same by asking yourself the question, what does this denominator have that that one doesn't? And vice versa, and matching them up with as few factors being multiplied as possible. See you later.